This is actually one of my favorite classes because uh, programming is the thing that makes games different from all the other media that's out there, is the ability to create interactivity. And so, and it can be daunting, especially when you see like, programmers who are doing like insane, crazy stuff. I've worked with a lot of programmers who, like, I can't even imagine what a day in their life is like. People who are graphics programmers or network programmers. But the reality is that there's programming of all flavors, and there's also, there's a spectrum of programming, and on the far extreme end is like things that, yeah, most likely everybody in this room, including myself, is not going to even be able to get your brain around the concepts. But on the other end of it, you have gameplay scripting and ways to create interactivity that they teach kids in elementary school. So a lot of the things that I'm going to show you, like, even if they seem new to you, like, they're completely within your grasp. And I'm no expert programmer. I'm a designer by trade. But whether you intend to be, a artist, a designer, a producer, audio QA, any role in a game studio can benefit from understanding how to use coding to automate things, or to create useful tools, or to create gameplay. And so that's why I'm really excited to show you how to get your hands dirty and get started working with C# and Unity. One of the things I want to cover first is really kind of the basics of programming. I mean, it's really useful first to know like why it's actually useful. We're going to cover why it's useful, the fundamentals, things like variables, conditions, loops, and functions. And then we're going to get our hands dirty in the engine by creating simple movement to start off with, just making an object move using scripting. Probably one of the simplest and most introductory things you can do. We'll also work with spawning and despawning, how to create objects and remove them, because that can apply to tons of different gameplay. We're also going to use triggers, an invisible trigger that the player might step into to make something happen. The things that I'm going to show you can be applied really broadly to a lot of different types of gameplay. But first, let's just get a baseline. First, does anybody have any experience with programming? Yeah? What kind of programming have you done, Marcia?
I've done some Java.
Mm-hmm. Cool. Yeah, a lot of people get their start working with like web programming with like Java or JavaScript. When I was in college, that was one of the things that I was actually first realized programming could be fun and interesting, because the way I was taught programming was incredibly boring, like sorting things and creating databases, which it's hard to get excited about. But luckily, programming in a video game engine is immediately rewarding. Like, you do something and you see the result, and it's very visual, and you can interact with it, and it gets exciting. So the point is, though, that games rely on interactivity, which is an action that gives a response, and you do this using code. So what can programming do to you? It can make something happen when the player provides input. So the player does something and the game responds. It can keep track of things like the score or a win-loss condition. A lot of times we refer to something like a game controller or a game master for how this is actually done. You can use it to control AI to move, attack, and react. So tomorrow night's class for the intermediate students is going to cover how to set up AI in Unity using NavMesh to have them move around, give them directions, and so that's something that you could learn in the intermediate class if you decide to continue. You can learn how to connect the user interface to events and information. So provide information through the user interface and buttons that will be able to provide an input into the game, and much, much, much more. So there's a lot of different programming languages out there. Marcia, you mentioned JavaScript and Java here. C# is what Unity uses. C++ is probably the most common programming language in the video game industry. But Python, HTML. But although there are many different programming languages, some things are universal. You'll find them in every programming language. Things like variables, conditions, loops, functions. And so we're going to go through these and give you an idea. And you may already have some sense or have heard of some of these things. But for example, variables store information. Essentially, you can think of it as like a box with a label. That you can put things in the box, you can change what's in the box, but the variable is the box. So the label's the name of the variable, and the contents of the box are the value in the variable. So for example, I could create a variable with the that's called name, and the contents of that variable is Alice. Or I could have a variable called age, and the age is 25, or in my case, 50. And so you can use variables to do things. Like you can print hello name, and it'll print hello Alice, because it replaces this name with the contents of the variable, which is Alice. So the value has a type. So you have, like, for example, age is a number, name is text, but it could also be things like a game object or a sprite render or a box collider, or any of the things that you commonly come across in Unity can usually be represented by a variable that you can refer to. So, and the point is code refers to variables, and that's what makes them powerful. So they're useful because they're reusable. You might define a variable once and refer to it different times in code. The value might change. You might check and see what the value is now and what it is later. So it's reusable. They're flexible. When the value changes, you only need to update it in one place. So if I have name represented in code in a lot of places and I change it from Alice to Brian, then all of those places where that variable are in the code get updated. So it saves you a lot of effort. It's also really readable if you give your variable an intelligent name, which is super important, then it makes your code make sense. If you name your variables like 1, 2, 3, 4, 5, or like 0, 7, F, 3, H, blah, 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 it's not gonna help you a whole lot. But if you give your variable a smart name, it'll make it so that when you read the code, it makes sense. So next, conditions. So we use conditions a lot, and basically a condition is a statement that lets a program decide whether to do something based on whether that condition is true or false. So that's important. A condition always evaluates to either true or false. So for example, if age is greater than or equal to 18, right, you are an adult. If otherwise, right, you're a minor. So conditions allow us to test variables and do things based on the results of that test. So you can have comparisons like, greater than, less than, equal to, or not equal to, or logical operators like and or and not. This will make even more sense when we start getting in and using it. So I'm going to stuff things into your brain right now that you maybe have like a loose grasp on, but it'll make even more sense as we use it more and more. And so why would we use conditions? So they allow your program to make a decision based on the input or the environment or what the current state of the game is. It allows you to create dynamic and interactive programs that respond to things. And they handle different scenarios. And again, it allows your code to be reusable and apply in a lot of different ways. It allows you to write something small. And in a way, you can think of creating code like creating a tool. The tool, once you've created a tool, it might take effort to get that tool right, but once you've made it, you can use it in a lot of different cases. And a lot of programmers take code that they've written and reuse it. And it can really speed up your work. And that's one of the reasons why you want to think about not just how this code can be useful in this specific case, but could this code be useful in a general sense? Maybe I could write it in a way that makes it more reusable. So loops are the next fundamental. So a loop is something that is going to repeat a block of code. So for example, you can see here, while count is less than or equal to 5, do this. And so something is going to change the value of count. And this is going to keep looping until count is greater than 5. And so you see inside the code, it's incrementing count. So when count's 1, it runs, 2, 3, 4, 5, and then it stops. So It's useful when you need to perform a repetitive task or when you need to test something over and over again. And there's several different types of loops. So what we see a while loop here. There's something called a for loop. There's a for each loop. And so depending on what exactly you need to do, you might use a different type of loop. And you may know how many times you need to loop through it in advance, or you may just want it to keep looping until something happens. So why are they useful? You can iterate over a bunch of data. So if you have like a whole list of things and you want to check every single one, you could do that with like a lot of if statements all in a row, and it could be like this long, or you could write a single while or for loop. That would be very short. So it condenses your code and allows you to do something repetitive over and over again. So you can repeat until a condition is met, like waiting for the user to give input or running a calculation until you get the right result. And it lets you write cleaner, more concise code. All right, next are functions. So a function is essentially a block of code that performs a task that can be reused multiple times. So a function lets us take code and package it up. You can think of a function like a tool. Generally, you're going to name a function something that makes you understand what it does. And then you can call that function or use that function whenever you want to do that thing. So this function is called greet. So if anytime I want to greet somebody who entered the classroom, I could call the greet function. And so I can write it once, and then for each person who comes through the door, I could run that function and welcome them to class. So functions are ways to package up some code so that it's easy to use it over and over again. So you can separate a task into smaller manageable parts. Sometimes when people write code, a very smart way to write code is to actually first go through and think, what are the things that this code needs to do? And you could actually say, first I need to get something, then I need to test it, and then I need to change it, and then I need to return it. You could make each one of those a separate function. A lot of times people will do immediately kind of just like write down what each verb is or what each thing that needs to be done without even adding the code inside, because then they have almost like an outline, like you might make a bulleted list or an outline for a presentation you're going to do, and then fill in the details. So it helps make code more organized, more readable, and more modular. You're seeing a common theme here. So key parts of a function. So the declaration is this part at the top here. And what it has is it has the name, function name. The function will take in some information that it's going to use, and those are these parameters here in the parentheses. And then it will return a value. Essentially, you're telling the function, hey, you have a job. Here's the things you need to do the job. And I expect that when you're done with the job, you're going to give me back something I need that's useful. And so the function takes the things it needs, does something to them, and then sometimes it returns something. Not all functions have to return something. Sometimes, the things that they do don't require them to return something. So this might be void. And that's what void means. I don't return anything. Otherwise, it has the return type. It might return an integer number. It might return a string, which is, a sequence of letters. So I mentioned the return type, and I mentioned the parameters. And the body is everything in between these brackets. And so whatever is in here is the code that executes. And if I'm returning something, you'll see it say return whatever it's returning, the value. So they're useful because code can be reused, it's modular, breaks things down into pieces, and it makes things a lot more readable. And it's easier to maintain. So when it comes to programming C# and Unity, what we're going to do is, so when you installed Unity, by default, you probably installed Visual Studio, which is kind of like it's a text editor like Notepad, but it's built specifically for programming. And it makes your code much more easy to read, and it adds a lot of useful things too. And so when we create we're going to create a C# script in Unity, and then we're going to double click it to open Visual Studio, and then we're going to look at a bare bones C# script. So let's do that. So if we go into our Unity Hub, let's just create a new Universal 3D project. And we can name this like, programming. And of course, once you do that, we know that it'll take a little bit of time for that to come up. So I'll continue to kind of go over, we're going to look at when you create a script in the Unity editor, it goes ahead and puts some things in the script. And we'll take a look at what those are, because you'll usually get like a start function, an update function, and I think that's it. And of course, it's all within the name of the script. And so we're going to show you the most basic thing and the most useful debugging tool, which is this function called debug log, which is a way of printing something to the console. So yeah, you can already see while we're waiting, in my example here, what we're going to do is we're going to create a script called debug print. And so you'll see here that this is what it comes with without you even adding anything. It has these lines that say using, which are like libraries. It allows you to get access to the functions that are in these libraries. And then this thing here that says public class debug print, that's the code that you're going to write. And it comes with start function and update function, but they're empty. So it's kind of, Unity saying like, chances are you're going to use one of these, so we're going to go ahead and give it to you, but you can remove that if you want to. Can anybody guess what's the difference between the start function and the update function? Oh, crap. Spoiler. Well, you're right, it does. And actually, these two forward slashes turning all this text green is how you add a comment. A comment is something that's just for your benefit, that's completely ignored by the computer itself. Because what you write here is actually compiled and turned into the machine code language that the computer runs. So this is almost like speaking a different language. But you're right, the start function is called once, whereas update is called once per frame. So does anybody know how many frames occur and how frequently they occur? Oh, it's all right. Well, gamers can be really particular about how fast a game runs, like in frames per second. So some people are like 30 frames per second slow. I need games to run at 60 frames per second. I have a machine that'll run faster than 60 frames per second. So games can run at different frame rates, and that's how many frames they produce per second. And that's what update is. Update is called once per frame, and that's, could be, most often, it's like 30 times per second. So if you put something in the update function here, if your game is running at 30 frames per second, it'll run 30 times every second, indefinitely. So you do want to kind of be careful of what you put into the update function, and there's ways at a certain point. You're not going to think too much about this now, but at a certain point, you will want to be concerned about just how you can make your game run smoothly as possible by programming in ways that you can take some of the load. Like there's certain functions you can call an update that actually take a lot of time and processing power and can slow a game down. If you've ever seen a game where the frame rate is going slower and slower, it's 30 frames per second, then it's like 20, and then it's like 10, and then it's like a slideshow. And that can be because of poorly optimized code. You two have probably come across this, right? But yeah, so now we have, let me switcheroo here to, I'm going to bring this where I can see it. And we're going to bring Unity up here. And so yeah, we're going to create our first C# script. So in project, you see you've got assets folder with scenes and settings. Let's be organized and first create a folder and call it scripts. And this is a very common structure, a very common way that people organize their folders in Unity. So if we go into the scripts folder, it's currently empty. If we right click and go up to create, you'll see mono behavior script. And so Unity's version of C# uses a library called mono behavior, and that's why it's kind of C# that's particular to Unity. And so let's call this debug log. Actually, yeah, debug log. And so it's super important that you get the name right on the script. You can change it, but the thing that's super important is that the name of the script has to be the exact same as the name of the class that's inside the script. So in order to see this script, you can see it here in the inspector, but that's kind of just like a quick preview in case you're kind of curious, but that's not how you work with the script. If you double click on the script, it should start opening up Visual Studio. So here's where we'll find out if your Unity is set up correctly. Yeah. So you have your debug log script, and you've double clicked it, and you should have it open up in Visual Studio like this. What we're going to do is we're going to write our first command in C#. And what we're going to do is we're going to use the start function, which as Martin pointed out, or no, Carolina pointed out, we know that it executes once, and it executes just once when once before the first execution of update. So let's see the difference. So what we're going to do is we're going to type debug, and you'll see as you start to type, it's starting to suggest things for you. This is something called IntelliSense, and in a way, it's not really AI, but it's like it's a suggestion system built in it to help you type code. Is yours not showing up? So is it you type debug? I think you might have to start with well, for one thing, it is case sensitive. That's the thing about code. If you make any little mistake, case, the wrong kind of thing, it's not going to work. So you can see when I type log, it gives me a bunch of suggestions. And you'll also see if you type after log, if you type a parenthesis, it automatically gives you another parenthesis to close it. So it's trying to be helpful, but sometimes the help it can be a little confusing. So, but you can see, all right, now that I've typed debug.log, it actually tells me, okay, you're writing this thing that you're referring to, debug.log, and the message, and it'll tell you what this function does is it logs a message to the Unity console. And it's expecting this message. So if I start with, I start to type gosh, I've forgotten what that thing is. Quotation. So I type a quotation mark. So if I type every program, most programmers in the world have started out with the classic hello world. And if I tab and then do a semicolon, those red squiggles go away. Now, if you don't have exactly these words in this order, then chances are you're going to still have that red squiggle and some tiny thing is wrong. Essentially, once you've typed this, you'll see that there's a star up here at the where the name of your file is. That's to let you know you haven't yet saved this. And so if you jump back into the engine, like it's not going to know that you've done this. So you have to save any changes you've made. So once you've typed the debug log parentheses hello world with the close parentheses, or with a semicolon at the end, and then saved it. So now if you jump back to Unity, chances are it'll take a second to say, hey, we're compiling. And so now you might say, okay, I wrote a script. Like, let's run the game and see what it does. Any thoughts on what's going to happen? So now, if you go back to Unity and you run this game, you're expecting it to print hello world to the console. But there's the console and it's empty. Now, so the point is, just because you have a script in your project doesn't mean it's going to run, because the script has to be in your scene. So your scene, the things that are in your scene, the things that are in your hierarchy. So we need to, a script will only run if it's attached to something in your scene. So for example, what I would do is create an empty game object and call this like, debug. And so this game object is empty now. But what I do is I take my script and I drag it and drop it onto that object. So now the script exists on a game object that's in the scene. So now, when I run the game, you'll see in the console, it says, "Hello World." Wow, you did your first line of code. So now we know that in order for a script to run, that we have to have it attached to a game object that's in the scene. Now, let's take a look at the difference between this command that's in start. If you highlight it, right-click and cut, put it in update and paste, and then save. Let's look at the difference. Absolutely. So what happens is, this line, debug.log, highlight it and cut it. You can do Control-X, or you can right-click it and click cut. So we're just going to cut it, and we're going to paste it into update. So we're just moving this function call, from start to update, so that we can see the difference between these two things. Because when we put it in start, it printed once. So since we know that update's called once per frame, chances are we're going to see a lot of these when we switch back to Unity and run our game. So once you've cut and pasted, make sure you save the file. Then come back to Unity, make sure that you can see your console, and then press play. So now, I have this button called collapse on, which collapses everything, but chances are you don't have that click the way I do. So now what you see is Hello World is printing continuously, and if you look here, there's more than 999 of these in the console. It's going to continue printing constantly. So that's update. In fact, it's printing probably 30 of these per second. And in fact, if I pause my game, I can look and see, like, okay, let's see. The most recent one was at 3838. So let's see, 3838. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So there's like, it looks like, within this 1 second, Hello World printed well more than 30 times. It's because this game has nothing in it, and so it could run really fast. It's probably running in excess of 60 frames per second. So now you have printed something to the console. Now you might think, well, Brian, when am I going to ever actually use this? But it's actually, this statement is one of the most useful debug tools that you will have, because you can put this somewhere in your code. If you're thinking, why isn't my code working? You can put debug.log, whatever statement you want, and put that in a place where you expect the code to get to. And if you see that statement print in the console, you know it gets there. If you don't see it, you know it isn't. So actually, one of the most fundamental debugging tools is this debug.log statement, because you can have a lot of code, and if you want to know why isn't it getting to here, is it getting to here? Put in a debug log. If you see that print, you know it's getting to that point. So it's one of the easiest and most fundamental debugging tools. But now let's do something more interesting. Let's actually create movement using a script. So what we're going to do is, hey, we might come back to this script, so let's create a new script. And what we're going to do is we're going to create a script going to go back to Unity. In our scripts folder again, next to debug log, we're going to create a new monobehavior script, and we're going to call it move object. Now we're going to make capital M, OVE, capital O, BJECT, and then hit enter. Now this is a type of naming that's very commonly used in programming. Pretty sure it's referred to as camel case because it's like the humps of a camel. But the point is you capitalize the first letter of each word. You see, in the name of a script, you're not allowed to have spaces. You're not allowed to have periods or weird things. You have to have just letters. But to make it more readable, you can use uppercase and lowercase. So it's much easier to read move object when the M and the O is capitalized than if it wasn't. So then you double click it, and let's open this up. So now, you remember when we talked about variables? Variables are containers that let us take something and do stuff with it. Actually, let me not go there too quickly. Let's actually do something else instead. Let's see, let's go down to our update function. Now, what we're going to do is we're going to put this script onto a sphere. We're going to create a 3D sphere in Unity. We're going to put this script onto it. That sphere is a game object. Virtually everything that you create in Unity starts out as a game object that you add functionality to. So we can, from this script, because this script is going to be on that sphere, we can refer to the game object, the sphere. And if we just type game object or start to, you can see that it's saying, hey, maybe you want to refer to the game object that this component is attached to. Yeah, that's what we want. I can actually hit tab now, and it'll finish that. So what I want to do is I want to refer to the game object that this script is going to be attached to, the sphere, and then I type a dot, period, and then I want to move it, and the component on the game object that handles its position in space is the transform. And so if I start to type transform, you'll see it says transform, the transform attached to this game object. I'll tab that as well. Now here I'm going to jump just to give you a better understanding. So for example, let's hop back over to Unity real quick and create the sphere so we have a sphere, and when I click on it, the very first component here in the inspector is the transform. And you can see the transform is what controls its position, rotation, and scale. So that's what we're referring to. We're referring to the game object sphere, and we're referring to the transform component that's on it because we want to affect its position. So if we type game object dot transform dot, and now when we hit that dot, we get this whole list of things we can do. Like it actually kind of helps us say, like, look at all the crazy things that you can do to this transform. One of the things that you can do in this list is translate. And that's translating means moving something in a direction a specific distance. So I can actually double click that. So now I'm saying the game object that this is attached to, we're going to do something to the transform. In fact, we're going to translate it. And if I start to open the parenthesis, you can actually see that there's 6 different ways that you can tell it what you want to do. You can give it a vector and say, translate it based on this vector that we gave you. Or if you click the down arrow, give it a vector and the space, the relative space. But if we keep going down here, this is something that's really easy to understand. We're going to use this. We're going to do the 4th one, which is transform.translate in X, Y, and or Z direction. So that's the version that we're going to use. So actually, we don't want to hit tab at this point. What we just want to know is this thing's giving us a hint. Hey, if I want to use this version of the translate function, then what you do is you provide it with an x, a y, and a z. And that it will translate it in that direction. So if we wanted it to go 1 unit in the x direction, 0 units in the y, and 0 units in the z, then we could put 1, 0, 0. And if we hit tab, we'll go to the end, then we have to finish off with a semicolon. And it even spaces it out nicely. So basically this is saying take the game object and move it on the x-axis by 1 unit every frame. Nope. In this case, it's lowercase. If it's capital, you're referring to the library of things that are under game object. By making it lowercase, we're talking about this specific game object that I'm attached to. So yeah, it's very important that you use a lowercase g here and not an uppercase. There is a distinction.
And what about
Transform should be uppercase because that's a specific function.
transform?
Oh, or my bad. Translate. Yes, game object is lowercase, transform is lowercase. So those mean this specific game object. Look, it's specific.
Object is capital.
But the O, exactly, because that's the whole camel case thing of making it easier to read. But yeah, you're gonna learn along the way that there are differences between capitalizing something and not, and it's very particular about the exact syntax. In fact, the beginner programmer's biggest headache is when something won't work, and it's because there's a comma instead of a period, or I didn't put a semicolon here. And a lot of what something like Visual Studio does is tries to help you with that.
But why is translate?
Translate is in capital, and it's also yellow because this is actually the proper name of a function. So in other words, we're getting access to, we talked about functions. This is actually a function, whereas these things are kind of like variable containers. So I'm saying, the specific game object, its specific transform, call this function, which is translate. So when we talk about a function, functions are always capitalized from the start. So in other words, there's an entire library of functions that you get from using Unity Engine. Let's see. Update is a function. Void is the return value. So start is a function. So absolutely, you're totally right. So let's give this a shot. Make sure you save. Now remember, when we go back to Unity, it's probably going to take a second to compile. But we have to remember too, okay, well, we have our sphere here. Yeah, we have to put the script, the move object, onto the sphere. An easy way to do this is to kind of collapse some of these other components so that you can see and drag this onto here. The other thing you can do, and the thing that Yeji needed to do because her drag and drop wasn't working, is you can actually add it as a component here. So if I find it here, if I start to type move object, I can add it from that menu. So I can either drag and drop it, or I can click. But we can see that a script is a component. All of these things here in the inspector are components. Unity creates game objects and lets you add components that give that object the ability to do things. So what we're doing is we're giving this sphere the ability to move, but it also has a collider, which means it'll bump up against things. It has a mesh renderer, so you can see it. It has the mesh filter, which is what gives it the spherical shape. And every game object has a transform because it all has some it has a position, a rotation, and a scale in space. Even things that don't need it have transforms. So now chances are, all right, get your sphere where you can see it. You might want to pull your game window to where you can see it. So we just want to know that, like, okay, let's go ahead and make it so that you can see the sphere in the game window so that when we start it, we'll be able to see if it's moving. So now when I start the game, I'm expecting that that sphere will go somewhere. And yeah, I was able to just see that it went off the side of the screen. So congratulations, you made a sphere move. The thing is, it moved really fast. And also, the other thing is we know that it's moving down the x-axis. So tell you what, it can make it easier to see how fast something is moving if we have some kind of a frame of reference. Like it would really help if we put some like ground underneath this thing. Well, first I'm going to do is I'm going to click this orientation gizmo, so then I know which way that it's going to go. You see, I know that my script is having this ball, this sphere move in the positive x-axis. And so if I turn on this gizmo here, it'll show me which direction that is. So I know that like, okay, it should be the case that my sphere here, like for example, if I switch to my move gizmo, it should move in the direction of the red arrow. So it's a little hard to see from the game window, but what will be happening is it'll move, well, if I select the sphere, we'll be moving in this direction. So what I want to do is I want to set up a 3D cube that I'm going to change into the ground, just to give me a frame of reference for this sphere moving. And what I can do is I can switch to the scale tool and then scale it to where it's kind of like long and flat like this. Look around at it and say, okay, well, you know, this is probably going to be easier. One, this global volume is annoying me because I keep unintentionally clicking it, so I'm just going to delete that. My sphere is at 0, 0, 0. That's cool. My ground isn't, though, so I'm going to reset my ground before I do this scaling. Scale it down, stretch it out in the X, make it a little lower. So basically, you want to get something roughly like this. And you might double check how it looks from your game window, because what we're going to want to do is try to figure out how we can slow this sphere down, because we want to actually see it moving smoothly down this runway and not have it fly off the end. So obviously moving at 1 Unity unit, 1 meter per frame, which is more than 30 meters per second, is very fast. So we're actually going to use a variable to slow that down. So once we have this set up, now what we can do is we can switch back to our move object script, and we know that like, okay, we do want it to move, and update's a great way of doing it, but this value is way too fast. We need a value that's smaller than that. But instead of changing that value over and over again, what we're going to do is we're going to use a variable, and we'll actually be able to adjust this variable in the editor rather than having to jump back into Visual Studio to make every little change. We can actually create a variable in the script that we'll be able to see in the inspector here, and we'll be able to change it. It'll be on, it'll be in this section, the move object section. And the way that we do that, so we don't want to be inside of start or update. We want to go above start, but still within the brackets of this class, move object. And we want to type first the word public. There's 2 ways to define a variable, public or private. Public means you'll be able to see it in the inspector. Private means that it'll be hidden in the inspector and it'll only be accessible to this script. So if we type public, the next thing we want to do is we want to figure out, well, what kind of a variable is it going to be? It's going to be a number, but there's different kinds of numbers. There's integer numbers, you know, 1, 2, 3, 4, 5, -2, -5, -10, 1,000. And then there's what we want to do is we want to see actually, like if I put my mouse over the translate function, it's going to tell me again, translate takes a float for X, Y, and Z. A float is a decimal. and it just happens to be a decimal of so many places. There could be a long that has even more places. So we can't use an integer here. It actually automatically converts this 1 to like 1.0. So basically we want to type public float, and then let's give our variable a name like move amount, and then semicolon. Actually, let's go ahead and give it a value while it's here. We can actually say move amount equals 1. That'll be a starting point. So public float move amount equals 1 semicolon. So that is our that is our variable. And what we can do is if we double click to select the word move amount and hit Control C to copy it, and then highlight this one and Control V. So now, technically we have the same thing. We have what used to be 1 is now the variable move amount, which is currently equal to 1. But because it's public, we can access it and change it from the Unity editor. Now again, make sure that you click Save. And then when you switch back to Unity, you might have to hold on for a second while it compiles. When you select your sphere, note that here in the inspector, you now have a new property called move amount, and it's set to 1. And you can actually change this. If you put your cursor right next to, not in the field, but right next to it, you see it turns to 2 arrows. I can actually change this here. And so I can adjust that to be what I want, and I can Control Z to get back to it. So for example, if we know it's going too fast. So what if we make it half of that? If we change move amount to 0.5. Now, if we press play, we expect it's going to move not as fast. Still moving pretty fast. Now we could jump back and forth, kind of, stopping the game and then making a change and starting the game again. But one thing we can do is actually make that change while it's running. Now, one thing I want you to pay attention to, so note that okay, we start out with the move amount 0.5. We start the game running. Now it starts going really fast, but I can slow this down and wait. I can actually go negative and make it move backwards. See, I can drag that value. I can even set it to 0 and have it stop. So if I want to really say okay, well, what's a nice stroll for our model to stroll down the runway here? I'm finding that 0.02 is working pretty good. Now the thing is, this is something that everybody screws up at some point. You find the perfect value while the editor's running. While the editor's running, you're making changes, and you say, oh wow, 0.2, perfect, love it. And then you stop running the game. Oops, your move amount went back to the value that it was before you started playing. That's because any changes you make to variables while the game is running aren't saved. So you need to make sure you remember that. A trick that I use is actually to screenshot it. And then, especially if you're making a bunch of changes to multiple things. So get to where you've got a value for move amount that gives you some reasonably slow movement to where you can see it kind of looks like somebody walking down the runway. All right, so we're going to learn, I think we have enough time to learn one more trick. We'll learn about spawning. We may not get to triggers, but I can totally, I can also give you a video to cover that. So let's see. So the next thing we're going to do is that we're actually going to create a new script that is going to spawn an object. So actually, so if you put your main camera on your sphere, let's disconnect it. Because what we want to do is we want to have just this sphere. Because what we're going to do is we're going to use that sphere and we're going to create a prefab of it and then spawn a bunch of that prefab. So for example, you can imagine that you might have taken this sphere, changed it into your character or your enemy in your game, or a bullet, something that you might want to spawn a lot of, characters, bullets, mines. So what we're going to do is for that sphere, in assets, let's create a folder called prefabs. This is another very common thing. A lot of times in your game, you're going to have a bunch of prefabs. Prefabs are a way of packaging together one or multiple game objects so that you can easily create them. You could programmatically create spheres, but something that's way more generically useful is to create prefabs. And the way you make a prefab out of anything that is in your hierarchy is just to take that thing and drop it in a folder in assets, and it turns blue. So what I've done now is I've taken my sphere, I dropped it into the prefabs folder, which, yeah, gee, I don't know if you're going to be able to do that since you can't drag and drop. I wonder if you can. Did it? Okay, good, good. So now we have a sphere that is a prefab. Let's see, and let's just remove it from our scene now. And now, even if we delete it from the hierarchy, it still is something we can get from our project, in our project. So what we're going to do is we're going to create an empty game object in our hierarchy and call it spawner. So this is something, let's reset its transform and raise it up just a little bit. And so we know that, okay, the camera is looking at it. Can't see anything because it's just an empty game object. It's called spawner. Now we're going to create a new script. So if we go to our scripts folder, and right next to debug log and move object, if we right click, click create mono behavior script, and we're going to name this spawn prefab. And again, we use capital S, capital P, all one word. So when you right click in your scripts folder, if you go to create mono behavior script. So when you've created it, double click it to open in Visual Studio. So now, previously, we know that if we create a public variable, we can access it in the inspector in Unity. Now this time, we are going to again create a public variable, but this time, instead of being of type float number, it's going to be of type game object. Now, this one is capital. So you want it to say public game object, capital G, capital O. So this is a variable that holds a game object. And we're going to name it like spawn object prefab, or whatever you want to. But you have to end with a semicolon. So what this lets us do, it lets us, in the Unity editor, we can give this script a game object, in this case a prefab, and it's accessible to this script. The script can do something with that prefab. So what we're going to do is in update, we're going to type, again, capital G, because we're not referring to this specific game object. We're referring to things that we can do with game objects. When we type capital G, capital O, game object, we're saying, of all the things that I can do with game objects, I want to do something, and I want to instantiate. So if you type capital I, you'll see it says, hey, instantiate will clone the object original and return the clone. So we're going to instantiate the spawn object prefab. And if I start to type SP, the very first thing in the recommendations list is that spawn object prefab, and I can just hit tab. And that's the same thing. It kind of knows, hey, you previously defined a game object variable and you're writing a function that takes a game object variable. This is probably the one you're looking for, right? And you're like, yeah, it is actually. Tab, semicolon. So what this does, and if we want to know, we can just mouse over the word instantiate. Let's see, I think if we go over new, there we go. So the game object class is everything you can do to game objects. Instantiate takes a game object. And so if we save this, no, don't open the folder, Brian, save it. So your script should look like this. Don't forget to save it. Hop back over to Unity. Now remember, we have to first click our spawner game object and put the script on it. But it's not ready yet because you'll see we do have this field, spawn object prefab, but we haven't yet told it what prefab to spawn. And what we do is we can tell it to spawn our sphere if we go to prefabs and drag sphere into that. So now we've taken a prefab, provided it to the script, and that's the thing that we're going to instantiate. So this spawner should instantiate one of those every frame. So we're going to get a bunch of spheres. Let's check it out. So now you can see that we're instantiating so many spheres so quickly that they're actually pushing each other out of the way. And we have this pretty much like a giant caterpillar of spheres. And they're being generated like, 30 per second. So, hey, now you know how to spawn things. Now you know how to create them. In fact, you could even combine these two things. You could say, hey, you know what? That I have a script that will move an object at a certain speed on the x-axis. These things are actually, they're moving down the x-axis, but only because each new one that's created is pushing the one that's already there because they have a collider. In fact, if we went to our prefab for our sphere and uncheck sphere collider and now run it, instead of those pushing each other out of the way, the collider is no longer there. Oh, actually it is. That's kind of weird. Oh, it's because the sphere has move object on it already. My bad. So that's the reason why. So what we really have is we've got our sphere that has our move script on it, and then we have a spawner that's creating the sphere at a certain rate. So in fact, if we went to this sphere and changed that move amount to be fast, like for example 1, we can change that value even though it's in our project folder, not in the scene. We can still say, okay, every time you create a sphere, that sphere is going to move down the x-axis. Let's change that so that it's faster. So now you see they're spaced apart. In fact, I think I can even change this value now that it's running and change how quickly they're being created and the amount of space in between them. So you're actually combining those two things. And yeah, you're creating a whole lot of spheres. So in fact, if you look in your hierarchy, it just keeps going and going and going and going and going. Now, luckily, spheres aren't terribly resource intensive, so it's probably not going to crash your computer unless you got a potato. But now you have combined the move object script that you put onto your sphere with a spawner that creates the sphere. So you can almost imagine, like, actually, if I were to put this spawner on the end of a gun that the player's carrying, I now have a gun that shoots bullets as fast as I want them. If I were to go to this sphere and disable that movement, then they'll probably all just pile up on top of each other. Let's see what actually happens. Yeah, they do. So I'm still producing tons of spheres, but they're all being produced, because they're not being moved by the move script, they're all right on top of each other. I could even click on one and raise it up here and be like, but it's still creating tons of spheres. So does anybody have any question about what we've done here? Like whether it's about like spawning by using the instantiate. So we have the spawn prefab that uses game object instantiate. We have move object, which uses transform translate. We got this debug log that prints a debug statement to the console. So those are the three things that you've learned along the way. You have any questions? Or I can try to see if we can do the last thing. Actually, no, because it involves the next thing would be triggers, and we kind of need something to enter the trigger. What I'll do is we only have like 10 minutes left, and so what I'll do is I'll go over kind of your I'm not calling it homework, I'm calling it your game development challenge. So let's talk about your game development challenge for the next week. So yeah, I have a lot of like clever slides here. Oh, so the thing that I was going to show you next, if there was time, is that we would use the third-person controller and get it into here. We could set up an invisible collider that we set to as trigger, and then we could use the function onTriggerEnter and print out a debug log when the player steps into the trigger. If onTriggerEnter, if the game object has the tag of player, print this. So many possibilities. So you can imagine all the things you can do. If you can create objects, you can move them around, and you can tell when an object, including the player, enters a specific trigger space. And so the thing that's not homework, it's a challenge, is use scripts to create interesting events in a project that you're working on, whether this is a game that you're actually actively working on or just like dabbling around. But demonstrate the use of moving using translate, spawning using instantiate. We didn't cover despawning. That's actually something that you can use a command called destroy for. And triggers you also didn't use. ChatGPT can be super useful if you like, for example, let me just show you. I use ChatGPT so much, it's like the first thing that comes up when I type the letter C. But if I were, for example, if I had screwed something up, let's see. I'm like, oh no, I get this error when I try to, there's something wrong with my code and I don't understand it. It says there's an error. If I were to copy this and say, copy the whole thing, and then go over to ChatGPT and say, hey, I'm using Unity 6 and this script has an error. What's up? And then I paste my script in there. And it tells me, the issue is that your script is missing a semicolon at the end of debug log hello world. Here's the corrected script. Semicolon added here. So like we talked about with Antanas, I'm butchering his name again, is that like ChatGPT can be useful if you're asking it to explain what is this? What error is happening? It's like, so it's like, all right, do you want, it'll always end with a question trying to keep you involved with it. But it's like, you could say, I don't understand what the update part does. Explain it to me. So a great way to use ChatGPT is to ask it, show it some code that you don't understand and say, break this down for me. I don't understand what this is, how it works. And ChatGPT will explain that to you. Or, say, ChatGPT, I want to do I want to have a script that that does something when the player steps in a trigger. How to do. There you go, on trigger enter. And it's going to explain step by step of like, what you would do, why you would do it, how you hook it up. It'll write the code. The thing to not do is just to blindly copy the code, paste it in, and say, cool, done, go on to the next thing. Make sure you understand the code that it's writing and ask it to explain some of the code. That's how you learn. And actually, I know the recommendation was like, go out and get a book. If you learn from books well, that's totally fine. But this is a way to learn from a conversation with an expert. And the thing that's really good when you're using Unity and C# is there's so much information about Unity and C# on the internet that ChatGPT gets the answer right most of the time. The less information available, the poorer ChatGPT's answers are going to be. So if you ask how to do something in Unreal Engine, it's actually not going to give you a really great answer, especially with like blueprints and stuff, because it's really hard for it to give you a good answer in that way. One, the information is limited. Two, it's in a visual node graph that it has a hard time replicating. But when it comes to C# code, there's so much of that, and it's been used for so long, and the answer has been figured out so many times. Usually, it's going to point you in the right direction. So I think that it's a great tool if you're using it correctly. Awesome. Well, there's 4 minutes left, but I'm going to cut you loose early because I have undoubtedly stuffed your brain full of stuff, and it's spilling out. But trust me, this was the start, and the more you play around with coding, the more it's going to become natural. So yeah, I look forward to seeing what you create.